Fusion Mobile, quality e-learning experience on the go.
You're welcome back to the class. We'll be taking on our second topic titled number-based system. Number-based systems. All right. And our focus will be on basic operations on number basis. Basic operations on number basis. All right. There is nothing new about this. Mathematics has method of manipulating its operations. We have methods of manipulating its operations. When we talk about operations in mathematics, we talk about the operators that we encounter in our daily mathematics. In mathematics, we have these operators. We have the addition operator, or the one you can call the plus sign, or the addition operator. And then we have the subtraction operator, or the minus operator. Other operators are the division, and then the multiplication sign. All these are what we call operators in mathematics. Okay, there is nothing new about them. We're talking about what guides these operations. Operations in mathematical calculations are guided by what we call BODMAS. Where the B denotes brackets, O stands for off, which you normally meet in your mathematical computations as multiplication, and this stands for division, and then M stands for multiplication. A stands for addition, while X stands for subtraction. All right, we are good to go now. This entails that whenever you have a computation to carry out, if it involves a bracket, you have to deal with the bracket first, and then a follow-up will be the division if you encounter dividing numbers in the computation. And if you have multiplication, it will be the next operation that will take place, and then addition and subtraction. This is the sequence it follows. All right. For example, if you're given these combinations of numbers to operate on, assuming you're told to simplify the following. Okay, and then you are given 2, 3 times 5 plus 2, and then 4 plus 1 divided by 2. All right, so what you do first is this: you have to make sure the brackets are cleared first, and then you can divide, and then you can multiply, and then you can add before you can subtract, and then what you have will be the outcome of the combination of all these operations. The next slide follows. Remember, previously you have 3 times 5 plus 2 plus 4 plus 1 divided by 2. Okay, now remember, we have to deal with the brackets first. Dealing with the brackets, we have 3 times 5 to give you 15, still in a bracket, plus 2, 4 plus 1 gives you 5, and then the division follows 2. And then removing the bracket total, you have to multiply out. You have 2 times 5. That is why after brackets you have half. Okay, and then 2 times 5 will give you 10, and then 2 times 1 is 2, plus 1 you have 3, plus 2 times 5 you have 10, and then your division still stands 2. Alright, had it been this, you have to be in a bracket. It then means that the division goes for both 30 and 10 if it were to be given this way. Okay, if it were to still be in a bracket, then it implies that the division goes for both the 2 digits in the bracket. Alright, and you can write in this form. But in the case we have here, we just have 30 plus 10 divided by 2, so which implies that the 2 goes, or the 2 only applies on the digit 10. Now 2 dividing the digit 10 gives you what? 5. So the next line gives that we have 30 plus 2 divide 10 gives 5. Okay, and then addition follows, and when addition follows, you have 30 plus 5 to give you what? 35. And this is the outcome of applying all the operations on your BODMAS, and then you arrive at this. You don't actually need to jump any step. All you need to do is to follow the procedures sequentially till you get to where you have subtraction, which is the last operation on your BODMAS. Always try to follow the sequence. Okay, and that is that. I want us to talk about some other thing that guides your operations using your mathematical operators. Okay, like we said, the mathematical operators are plus, minus, division, and multiplication. All right, addition, this is subtraction, and this is my division, and this is my multiplication. Okay, all you need to know about addition is this. I would like to talk about the operator addition. I would like to talk about this addition. Now what do you need to know about addition? All you need to know about addition is this: that when two numbers, okay, when addition is guided by multiplication, the outcome is addition. And I'm only saying that when two positive numbers, or when two I'll be using addition to denote positive, and then subtraction to denote negativity. And so when two positive numbers multiply together, you will always obtain a positive number. Alright, and then when two when both a positive and a negative number multiplies, you will have a negative number. And then when two negative numbers multiplies, you have a positive number. And then when a negative number multiplies a positive number, you have a negative number also. So all you need to note between these two relations are that whether the positive number multiplies a negative number, or the negative number multiplies a positive number, the outcome will always be positive. And two other important things you need to note here are just that when two negative numbers multiply, okay, you will always have a positive number, and when two positive numbers multiply, you will have still a positive number. Okay, I think these are relationship you have between the operators, and then you need to know these two because it will help you when we want to do further computations in further classes. And these two be leading us to how to add and subtract binary numbers. We will not only be talking about binary numbers, but for our class today we'll be talking about only binary numbers, but in subsequent classes we'll be talking about other number systems, how to multiply, how to add them. But we'll be taking our first example on binary numbers. Remember, we said binary numbers are numbers that consist of 2 and 1. Alright, so we're talking about addition. addition and subtraction of binary numbers. And the numbers I'm talking about are zeros and one numbers. Okay, this is also as easy as it may be. Now look at what guides you. I'll give you a guide. My guide goes this way. Alright, since binary numbers consist of zeros and ones, so all operations will be limited to zeros and one. And so the first goes this way. The first guide number one, is that when you have two binary numbers, say 1 plus 1, it's equal to 10. Alright, the secret here is this: since 1 plus 1, the last digit on a binary number is 1. Okay, when it gets to the end of 1, it starts to count again. Okay, and then the next digit will be what? 10. Is understood? Remember that when we had our decimal digits, the last digit to follow up after 9 is what? 10. So it happens with every other number. When you get to the end of the number, the next digit that follows is 10. So 1 plus 1 is, instead of being 2, now it's, since binary numbers ends at 1, so the next digit being 2 should be 10. And the second follows like this. You have that 1 plus 0 is equal to 1, and the third guide follows like this: 0 plus 1 is also equal to 1, and the fourth guide follows like this: that 0 plus 0 is equal to 0. Alright, these are the basics of the guides. These are the basics of this guide. Some other derivations can be made from this. Because you may want to add 10 plus 1. Okay, and then 10 plus 1 will be equal to 11. Alright, and it follows that since 10 consists of 1 plus 1 to give you 10, now if you add another one, okay, being the 10 plus 1, okay, which will now follow that 1 plus 1 plus 1 is equal to 11. Okay, good. And the other computations follows just like this too. Now what I mean by that is that maybe when you want to add 11, you want to add 1 to 11, okay, you can use your long addition method, and then you have 1 plus 1. Remember, it gives you 10 because we are using binary, we're working on binary numbers, and then 1 plus 1 gives you 10. You carry over your 1 to this, you write 0 and pick 1 to the next digit here, which gives you 1 plus 1 again, which is 10. So all we are saying is that 11 plus 1 in binary gives you 100, and 11 plus 1 is as good as writing 1 plus 1 plus 1 plus 1 to be equal to 100. Alright, just like I said, deriving these other outcomes can be as a result of combination of complex other numbers, or trying to add up other numbers, then you get to outcomes like this. Alright, can move on to the next slide. Now the subtraction follows in the same method. I'll give you a guide for the subtraction, a guide on its subtraction. Alright, for the subtraction, my rule number 1 on my guide, says that when you subtract two binary numbers, assuming it's 1 minus 1, it gives you 0. Alright, and then I also have that rule number 2 follows as 0 minus 0 to be equal to 0. Alright, this one is understandable. And then the third rule follows this way. Rule number 3, you have 1 minus 0 to be equal to 1. Okay, we shall be using some examples to justify the little we have tried to do now. The examples we'll be doing 2 examples for the addition, 2 examples for the subtraction, and then 2 examples for the multiplication. All right, sorry, let me give you a guide on the multiplication. It's as simple as it used to be. It's something you usually know. It follows mathematically. Multiplication, okay. If you might not really like this, okay, that's okay. For the multiplication, the first rule states that 1 times 1, just like it has always been, is 1, and then rule number 2 states that 0 times 1, as it has always been, 0, and then whether you turn it to the left or to the right, I think it will always remain that way. Whether you say 0 times 1, it will still be 0. Okay, we shall be applying some examples. We shall be doing some examples. All right, example 1, add the following. Remember we said we'll be going by 2 examples. Add the following using the binary system. Add the following using the binary systems. If I don't want to write this way, I could say add the following binary numbers. Add the following binary numbers. All right, knowing that they are in binary, then you know that you have to use binary methods to add them. And then in my example, I have a to be equal to 1011 plus 1101. Okay, and then B, I have 101 plus 101 plus 123. Okay, 111, that's 1 in 3 places. Okay, so remember I said we'll be restricted to only 2 examples, and solution A follows this way. Solution A, okay, which implies you have 1011 plus 1101. Okay, remember from our rules we stated that in addition 1 plus 1, okay, 1 plus 1 is what, 10. Then I keep my 1 and then carry it over to this. 1 plus 0 is 1 plus 1 is 10 again. I keep my 1 again, and then I take it to this point. 1 plus 1 again is 10. I keep my 1 again, and to this point 1 plus 1 is 10 plus another 1 gives me 11. Okay, because we said it previously that 1 plus 1 plus 1 is equal to what, 11. Okay, because 1 plus 1 gives you 10 plus another 1 gives you 11. Okay, so the outcome of this in binary, the outcome of adding these 2 numbers in binary gives you the value we have here. All right, okay, lest I forget, they are all in base 2. They are all in base 2, denoting binary. All right, okay, so solving for the next solution, solution B. All right, for solution B, remember we had 101 plus 101 plus 111. All right, you can as well arrange in your long division method, and you have 101 101 111 operations being guided by addition. it doesn't mean that you wouldn't have operations where you have addition and subtraction all put together. It is possible, but then it's advisable you do each separately. You first add and then you subtract. Okay, and 1 1 1, that is 1 plus 1 plus 1 gives you 11, and then you write 1 and you keep 1, and then you move this one over to the next column and you have 1 plus 1 again, which gives you 10, and then you keep your 1 again. Move this one over to this next column. Remember that 1 1 1 gives you 11, okay, plus the one you already have as a carryover. Okay, when you add this, what do you have? You have as good as 11 plus 1, which gives you 1 plus 1, you have 10, and then carry 1 again, that means you have 100. So that means 1 1 1 plus 1 plus 1 plus 1 plus the additional one you had already gives you 100. Okay, good. And so this is the representation of these numbers in base 2. When you add the 3 digits, it gives you this. So all we are saying is that this implies that when you add these 3, it gives you 10001 to base 2. Alright, you can as well have a combination of both addition and subtraction all put together, but it's advisable you do them separately. All I'm saying is that assuming you're given this, assuming you're given b to be equal to 101 to base 2 plus 101 to base 2 minus 111 in base 2. Alright, so all you need to do is this: add the two first base 2 numbers, then subtract from the third one. So how do you add up this? You have 101 plus 101. Okay, 1 plus 1 gives you 10, carry 1, and there's nothing here, you bring down the 1 here, and then 1 plus 1 gives you 10 again. Alright, then all you need to do is, since you have this as the outcome of adding the first 2 digits 101 and then the next digit 101, okay, good, you can now subtract 10 10 1010 in base 2. You can subtract 111 from 1010. Alright, this eventually cannot subtract, so all you need to do is, just like in your usual subtraction, you can borrow digits. You can borrow digits from here, and this comes down to 0, and then you add to this, it gives you 10. 10 minus 1 gives you 1, because 1 plus 1 is 10. And then you can borrow digits from here, and here turns to 0, and here becomes 10. And when you borrow digits from here, here turns to 1, and here becomes 10. Alright, so that means 10 minus 1 gives you what? 1 again. And then at this point you have 1 and 1. 1 minus 1 gives you 0. Okay, so that means this operation will lead you to having 011 in base 2, or what you call 11 base 2. You can write without the 0 in the front. Right, going over to the next slide, so that we can do some other operations. I want to lay some emphasis on the subtraction method. On the subtraction again, let me lay more emphasis using examples. And then the next example that comes to my mind is this 10101 minus 111, all in base 2. They are all in base 2. Alright, and then I use my same long subtraction method, and then I have to set it this way. Okay, the operation there is subtraction. 1 minus 1 is 0. Remember from the guides. Now look at this. At this point, 0, 1 cannot be subtracted from 0. That is, 0 is less than 1, so we need to borrow digits. Now I'll start borrowing digits from here, and this makes this 10, and I borrow 1 again, this turns to 1, and this makes this 11. If I borrow 1 from here, this turns to 10, and then I give this 1, and it turns to 10. 10 minus 1 gives you 1, remember, and then this turns to 10 too. So 10 minus 1 here is also 1, and then what's remaining here, you just have 1, you bring down your 1. Okay, all right. So this is the outcome of this. So you have 1 1 1 0 in base 2. Okay, when you do this subtraction, if you do it carefully, you will have this. Don't mind my writing. Right, we'll be talking about other operations, on binaries, basically on binaries, other operations, and then we'll be talking about multiplication. So how does it really work out on multiplications? All right. All right, multiplication of binary numbers. Okay, multiplication of binary numbers. Remember that when you do your long multiplication method, you will as well encounter addition of numbers. Okay, just like in your decimal numbers, when you are given 289 times 12. Okay, if you use your long division method, you have 289 on your arrangement 12, and then you have 2 times 9 as 18. You have to keep your 8 and carry 1. 2 times 8 as 16 plus 1 17, and then 2 times 2 4 plus 1 5. Okay, and 1 times 9 as 9, and then 1 times 8 as 8, and then 1 times 2 as 2. Okay, this is the arrangement. You have to know that during the second multiplication, when the number 1 was to multiply through the digit above, you find that the numbering started from the second digit. Okay, and so do not get confused with this. All right, you can bring down your numbers. Here you have 8, it's been added to nothing, and then 7 plus 9 gives you 16, remainder 1, and then you have that 1 carried over to the 5 you have here, and then adding 1 to 5 you have 6. 6 plus 8 gives you 14, and then you can carry over the 1 to the next digit there, which is 2. 2 plus 1 is 3. Okay, this is the way you always have it in your long multiplication method. The same rule applies to binaries too. For example, you're given digits like 1 1 1 0 times 101, 1 1 1 0 times 101. Okay, you can arrange in your long multiplication method, you can arrange it this way: 1 1 1 0. Their numbers are all in base 2. Sometimes you may not need a soothsayer to tell you that the numbers are in base 2. Just look at the combination of numbers and then you know that they're in base 2, because there are no other combination of numbers that could make up a base 2 number if not zeros and 1. Okay, being multiplied by 1 0 1, right? Now 1 times 0, just from a guide, is 0. 1 times 1 is 1. 1 times 1 is 1 again. 1 times 1 is 1. All right, and then 0 times 0. Note where the second digits, when the second digit starts to multiply, the number follows from the second digits too on the outcome. And then 0 times 0 is 0, 0, and 0. And then 1 times 0 is 0. 1 times 1 1. 1 times 1 1 again, and then 1 times 1 1. Okay, all these are being guided by addition. All right, when you add this, it's as good as bringing down 0, and then here you bring down 1. At this point, to 1 plus 0 you bring down 1, and then at this point 1 plus 0 plus 1, which is as good as saying 1 plus 1, and we know is 10. You can write 0, and carry 1 to this. 1 plus 1, 10 again. You can write 0 and then carry 1 to this point. 1 plus 1 is also 10. Alright, this is the number you obtain in base 2. I think it's very simple. Alright, I'll be taking another example, as this is my example 1. Let me write that quickly. Example 1. Alright, on the next slide we'll be taking on example 2. Okay, and the example 2 will be taking on multiplication of this number. Example 2, we're taking off multiplication of this number. Alright, okay, for example 2, I'll be using 10101 times 111. Alright, okay, if I intend to arrange in my multiplication method, I have 10101 times 111. Alright, so 1 times 1 gives me 1, 1 times 0 gives me 0, 1 times 1 gives me 1, 1 times 0 gives me 0, and then 1 times 1 gives me 1 again, and then 1 times 0 gives me. Alright, on the second multiplication, okay, the second number below is multiplying the first line, and so 1 times 1 gives me 1, 1 times 0 gives me 0, 1 times 1 gives me 1, 1 times 0 gives me 0, and then 1 times 1 gives me 1. Always take note of your arrangements. Okay, you find out that once this second number starts to multiply, I shift to the second digit. Okay, and then again the third digit starts to multiply and I shift one more digit inside, and then I have 1 times 1 1, 1 times 0 0, 1 times 1 1, 1 times 0 0, 1 times 1 and 1. Okay, all being guided by addition. Alright, I can bring down my 1, and at this point I can bring down 1 too, because 0 plus 1 is 0. 1 plus 0 plus 1, okay, is as good as saying 1 plus 1, which is 10. Okay, and then you carry 1 to this point. Okay, then 1 plus 1 here is 10 also. You carry a 1 to this point, and then 1 plus 1 here is 10 plus 1, you have 11, and then you carry 1 over to this part, and then 1 plus 1 here is also 10. You carry 1 to this point, and then 1 plus 1 here is 10. Alright, this is what you obtain. With this, we have come to the end of the class on addition and subtraction of binary numbers and basic operation on number system. Okay, you have seen its implication when you add numbers and when you divide numbers. More importantly, the slide on how operators work is very important. This slide is very important because you have to note how these operators work. What happens when you multiply two positive numbers, what happens when you multiply to a positive and a negative number, and what happens when you multiply two negative numbers, or when a negative number multiplies a positive number. This will actually help you on how to manipulate your operators. Okay, and the guide on how to work on common algebras is the BODMAS, and so you need to get this down into your memory lane so that you wouldn't mix up operations. Thank you for listening.